Well, hello. I'm Jon McCoy, and I'm, of course, talking about .NET. So, are there pointers in .NET? What do you guys think? And where do they live? So, they live in a magical forest. You are correct. That's kind of where my research goes. It digs a little deeper than what you'll normally find, and it turns out they live inside of delegates. And delegates have private variables. One of their variables is im underscore pointer, and you've probably never seen it. But if you use reflection, you can see it, you can grab it, you can use it and manipulate it. And it's actually a pointer. And that's kind of where this research goes. It allows you that deeper level of control. And hopefully, as I get through this, you'll see how that becomes not so magical anymore and a little more real world applicable, or at least you can know it and keep that in mind. So what's the security in .NET? Anyone? Like, name a security feature. Code access security. So I have free DVDs. They're my training material, and they're from this year. And so as this year is almost over, I'm just flushing my stock. And so you want a free CD? It has videos, tools, white papers, everything you could need. Everything that you need to learn what I'm going to show you today. So what's another security feature? Do you guys use security? Do you know of it? Have you heard of it? Can someone repeat that? App domains. Okay, so that's kind of a shell that encompasses where you're running and contains a little bit of context. And there's a whole slew. Microsoft says there's all of these different choices. And when you're breaking out of the shell in .NET, you start having to go through these security mechanisms. And so that's kind of what I'm experienced in. I'm experienced in what security mechanisms slow you down, what security mechanisms you have to turn off, subvert, fix, and it's been an interesting ride. Like I said, Jon and McCoy, digitalbodyguard.com is where you'll find me and my research, and this is hacking .NET applications God mode, targeted at bringing developers and hackers to a lesser extent the ability to bend and control applications. As your developer, you develop applications. How about developing other people's applications? And, of course, leet speak. Thanks for having me here. Hackers versus the attacker. Whether you're a hacker that just enjoys going after something and playing with it and get in a little bit of trouble, or you're an attacker and you're just there to do damage and nothing is going to slow you down. That's kind of where this research goes. It's just a tool. It facilitates you to have much more power than you might otherwise have. That's what this research is. It's kind of pulling back the curtain to show you what you really can do. An application. It has the creative licenses. It has that intellectual property. It has all of these objects that we deal with on a daily basis. It has the locks inside of it, and it has the power of what it controls. And that's the core of what I see an application to be. And that's what we're going to attack. We're going to try and go after that in a fundamental way. This is what an application typically looks like. It's 15 threads all over the place, tons of classes, tons of objects, tons of memory. And how do you go up against it? How do you start taking a hold of someone else's application? It's kind of that black box of, like, how many of you have written malware or self-installing userless applications? It's an art. And that's what I'm here to show you. My tools that I produced are targeted at taking an application on disk and being able to edit it and make it yours. Change it in that fundamental way that allows you to have that program different. Grey Wolf is the tool that does on-disk editing. It's kind of like a decompiler, but it's targeted at attacking and editing specifically. Whereas decompilers try and get you some source code access or something like that. This is targeted at you want to go and affect some piece of software quickly. Specifically, this is what it does. we're going to look at attacking on disk. What is it? What do you need to do? What's kind of the process? Let's look at Microsoft Media Center. We've all come across it. We know it's there. It's something fun to play with, right? Here is the check pin sequence for Media Center. When you lock it, so your parental lock is on, this is the key sequence for validation. You can take this to be a generalized security check. When you enter it, it takes in a string. It then does a basic is this null check, and as it goes through, you can see it does a length greater than 0, but then it does this. Is a 0th character equals 58, which is a colon. So if the set password, which is what it's comparing, starts with a colon, do something different branch, is what this go-to block does. And it goes to, and there really are go-tos. They're really down there. And so you can see in a simple validation sequence, there's actually a branch. And unless you were brute forcing infinitely, you wouldn't necessarily find this. And with these tools, you can just look in there, see it, and know it's there and take advantage of it. Whereas everyone else might have missed it, you can quickly see it and make use of it. Let's look at that. You've all heard of Media Center. So we'll look at Media Center. This is a Microsoft product protected with their general software security. It's just a nice kind of intro that shows the potential. Come here, parental controls, and I don't know the password. So what do you do against it, right? Let's look at that. So here is what I would consider the basics of aggressive software. It's not necessarily good or bad, it's just a tool. You can think of this as forcefully installing software, and this forcefully upgrades Media Center. I can pick show the password and hack the password. It has a payload that's encrypted against this, which is nice for forceful software so people can't identify your payloads. It unpacks it and puts it into Windows and hooks it. And that's it. I've just installed a new upgrade to Media Center. And so as you can see, it's not that install process that we're used to. It's just, okay, I'm going to forcefully do this. And now we can come down here and put in whatever we want, and it succeeds. And so now that password validation is just subverted. I installed a rootkit, or bent the Microsoft product at a fundamental level. And I developed that with these tools that you'll see. Let's take it a step further. Here is a piece of software that you can put in 4 numbers and set the password to whatever you want, and you can get the MD5 hash of whatever the currently set password is. You'll notice it starts with this colon, and this is what's actually stored, that MD5 hash. And so this is, I think, 20 lines of code, and it took me 15 minutes to write, that this software turns around really quickly and has stability and all of that stuff we're looking for in standard software. Why don't we set it to all zeros? Change the password, set it back to normal, and I'll put Media Center back to normal. Yeah, you can see it. Okay. So it's not ones, it's all zeros. And this is kind of what I'm wanting to show. Aggressive software is not necessarily malicious. Maybe on your system, for whatever reason, you want to upgrade or change that sequence of validation. And that's what I'm bringing to you. You can just simply put a return true in place of all of that logic. And that's what this does. This checks a pin, it takes your string and returns a Boolean. So this return true is always good. And you can quickly do this in about 6 clicks. So let's look at kind of the dark side of this, right? What does it mean to go up against already aggressive software? So here is antivirus.exe. We'll open it up, and so maybe you find antivirus exe in your enterprise or somewhere. And here's what's inside of it. You can jump around its code, and it's obfuscated, and you can get back source code from inside of it. And it's not terribly useful because it's been obfuscated and lightly protected. And that's one of the first types of protection that you'll come up against. Click on this import, target antivirus.exe, and then deobfuscate it. And that's where this tool is targeted at attacking this software. Now you can quickly get in here, and instead of this hard to read code, it comes out a little bit cleaner, and it starts to be human readable. And that's why this is not necessarily a decompiler. This is a piece of attack software, or modification, or access software. And you can see this is the class, this is the constructor, and you can actually look inside of applications. It's pretty clean. That's attacking on disk. You can get much more effect from attacking in memory. So when you attack on disk, you can modify the executable. But here's what you can do in memory. So here's JetBrains, their .trace. I've come in and just modified it. You can reach into arbitrary applications and just start changing them in memory. Only impacting memory, not impacting disk. And here's a piece of shutdown software. I went in and pre-canned all of this, and I've always wanted this start timer here to be over in the .trace. So I'll pop it off of here and push it over here. And so now I have that start timer over here. And that's really handy because then I can just start combining these two applications and adding their functionality together and be able to combine Frankenstein applications running in memory. I can come in here and edit this to anything I want with a nice editing window. And it's very, very stable. This is .NET working at a high level. This is objects in memory and proper function calls. This isn't like some low-level hacks. This is features of .NET. And these tools bring those features to you for very cheap. So, and it closes up, and it's stable. That's attacking in memory. So you've seen attacking on disk and attacking in memory, what it can get you, why you would want to do it, right? When you attack an application in memory, here's a sequence. You start up the application, it turns on the DLLs, it all goes through Microsoft's security loading software. It becomes a process, and then you inject in and you deliver your payload. So let's look at that. I have two pieces of software. They're roughly the same. I'm going to inject into one and drop a payload, inject into the other one, and drop a payload. I'm going to drop the same payload into two applications to show you the flexibility of this, to give a little bit of what someone might want to do. So here's the first piece of software. It takes a password. Second piece of software, it takes a password. And if you don't know the password, it doesn't validate. One of these is 64-bit, the other is 32-bit. This is Gray Dragon. It injects you into arbitrary .NET application. You drag and drop this onto here. It targets it. It finds that it's a 64-bit application. It's PID for the process, and it injects a payload. This is a stager. It takes any arbitrary executable and loads it inside of your target. So any executable that you have, this will run it inside of the process space of your target. So whereas you have an app domain, this creates another app domain with your executable in it, inside of your target process. So you're sharing memory with your target at this stage. I'll take this payload, drop it in here, and load it up. And so now this payload is inside of this process space. This goes through and gets the hash for this password, and then I can brute force it. That's what this payload does. I'll take this, target the other one. This is 32-bit, and this is kind of where it's different than C++. You don't have to have 32-bit, 64-bit targets. This is targeting a 32-bit. I'll inject it just the same, take the same exact payload and drop it in. And as we all know, that's MSIL, and it's agnostic to its target, right? It finds the hash for this, and so I can start brute forcing it. Start brute forcing them, and when it finds, it uses the password validation of its target to actually check all of the brute forces. So it reaches straight into the logic of the application to find the validation sequence, and it reaches in to find the hash, and then uses those to be a ubiquitous brute forcer that can quickly be augmented to any target. So this one is found, and this one is found. One of them was traveling much faster because of the validation sequence is different on them. I thought it'd be nice to type it in and show the password that was found to be correct, and it validates. And so with this, you can see how when someone says, oh, here's how you brute force a zip file. Here's how you write your own brute forcer. And you can, of course, take that brute forcer, drag and drop it into my tools, and see the code for it. And so here's the brute forcer. And you can look at the code. So this is how I did the stupid cracking of the password. I just did numerous 4s, which isn't the best way to do a brute forcer. And you can see how I locked on, how I did each single step. You can see if I'm doing any other modifications and all of that. You can read my source code. And you can read any other source code. .NET and all programs, not just .NET, Java, C++, everything is source code. All those commands for every single thing the program does is in there, because source code turns into commands, right? And commands go back to source code. It's just, if you want to do that to C++, you have to spend $2,500, $1,500, whatever it might be to get a hold of a tool. And now in .NET, I can develop this much easier than I would have in C++ and give it to you for free. And this is a free tool up on the website, Grey Wolf, and it's, what else would you guys want to be able to do to a program? Like, say you were gonna attack it, like, any ideas of what you might wanna do? Like free everything training, demos, applications, practice malware, practice, there's a keygen on here, so you can see how a keygen is written and the key that it unlocks. Like everything you could want is on here. So, any ideas? Like what might you want to do to a target? Anything? You guys just would never want to affect another application. You couldn't see any reason you would ever want to. Sure. You want to write a method? Override. Okay, well, here. There's not enough for everybody, so I'll hand them out arbitrarily. So yeah, like here's editing the IL. And so, like take this for instance. Here's this string, and I'll open up an editor and replace this string. And so that's what it takes to edit inside of your target application. You can come in here and change this true, which is, let's see, this one probably. You can change this branch on true to branch on false. Click save and save it out. And you can come in here and change this happens to be a private, we can make it a public. And so as a developer, you can go in and have that access that you've always wanted. You came up against a library and you can't get to that one method, or that method doesn't do what you want, and now you can just change it. And that's what you have at this point, the ability to edit. You have the hex of the function, you have the class view, and you have the resources of the application at your disposal. And this isn't complete, but I'm still increasing the full feature set. So that's a brute forcer. That gives you the ability to reach in and edit an application. This one happens to be a brute forcer, so it's in memory. It's not editing on disk. Yeah? Would that be a security feature? So There is a security feature of signing an application. Microsoft gives you a developer key, 1024-bit crypto, and that media center that I edited was signed. And I could have the Microsoft key. It is out there. They are floating around. But it turns out that Microsoft actually turned off code signing. So, code sign checking. So they validate the key, but then they don't validate that the key matches the DLL. And this makes sense when you think about it, because say you're talking about a video game, right? And you have 200 megabytes of DLLs. You have to hash every single bit in that DLL to load it if you have that signed key validation on. And so your boot time without an SSD is 20 seconds. And so they turned it off for efficiency. And then they're like, well, even if we turned it on, you could bypass it. You could go into the operating system and turn it off. You could compromise the key checking validation sequence. And they came up with all sorts of reasons why. And in the end, it's off by default. You can go into the registry and turn it on. You can put it in the manifest and turn it on. And then, of course, you can turn it back off. So it's your box. Then key checking is however you want it to be. And Grey Wolf automatically takes the key of your previous application and puts it on the new application. So the key is no longer correct, but it is a good key. So it is signed properly. So like I said, that piece of Grey Wolf is for attacking. Everything that I can come up against as a way to stop it, I'm putting in to beat it. This takes us from the old days of C++ and all of our old things to the new ways of application development. We don't develop in assembly code anymore. We don't develop in C++ anymore. And the tools for attacking are developing slowly into this new paradigm. We're trying to go towards something more powerful and more capable. This is IL. This is what underpins .NET. You all know this? Some of you? You guys just don't know about IL. You've never heard about it. Okay, how about some hands? Okay, see, you guys know there's IL down there. And IL is the matrix. It's what you're really coding. It's VB, it's F#, it's all of the languages is IL. IL is a superset of .NET. You don't necessarily need to know it, but it helps when you're staring at IL of other applications. Whether it's protected in some way, if you can gain access to the IL, you can quickly edit it. And that's what we're looking at. We're looking at being able to reach into an application and take this insurmountable thing and make it easily editable, whether it be standard software to business or something on your home PC, right? Any other questions? Like, I would like some user feedback. Does this look interesting? So what would you guys want to attack? Like, let's hear an idea. What would you want to use it for? Yeah?
I'd like to be able to override the string class.
Override the string class? Well, just go in and find it in the framework and edit it. The framework is .NET. Just like anything else, yeah, you can go through and make the privates in the .NET framework public. You can go in and gain access to those variables you were never supposed to gain access to. And of course, attacking at memory, I also did a whole paper on using reflection to bypass and gain a hold of all of those and how to bend everything in runtime through reflection. And on my website, you can find a paper for how to move between app domains, how to move around the object structure, how to inject yourself into another process, and then make your way to the SQL object, and then take the connections to it, pull it off, put a new SQL object there, and then let it go. And it's easy and it's stable. And I've tried to make this as user-friendly as possible. So to make you as powerful as possible. When you go up against an application and its security features, that you don't have to worry about can you do it. It's just a matter of time. Usually between 2 minutes and say maybe a day, 2 days at the most, for getting past whatever your target might be. Let's look at that. When you connect on disk, you gain access, you decompile it, you infect it, take the changes that you want, You exploit it to take advantage of its security features, so maybe they're doing crypto that happens to be weak, or you weaken it even further, or make it stronger. You can remold it in whatever way you can really think of. You're developers, right? You just now have the ability to develop other people's applications. You can take their executable and drive it like it was a library. And that's what this is bringing. This has been done since the beginning of computers. People did this with assembly code. People did this with C++. This is old technology. It's just we kind of forgot about it. We kind of figured, oh, it's really hard to edit a program post-compile. We've all heard about, like, people would compile it, and then they would have to fiddle with it and change it well beyond there, and then they didn't have the source code for it. And now that you can do the exact same thing. You can make your application and say you want to put a unique registration key in every single one, right? Then you can just go in there and type in your registration key that's unique to this payload and then ship it off to someone. And you can make those one-offs, you can automate all of this, and it's a whole new paradigm of getting out of that it's compiled, it's done, it's locked down. These are the weak spots. When you come up against some type of mechanism, you can usually beat it with one of these. You can flip the check, so if it's password validation, you can set a value, so if it's checking to see if something meets criteria, you can cut the logic short, you can just return true at any point and gain access to unknown variables inside of your target. So registered equals false simply becomes registered equals true. Password validation of did they enter it correctly suddenly becomes did they enter it incorrectly. Is registered becomes yes. SQL cleaning? Yep, sure did. Send it to the server. It's totally clean, don't worry. And that's where we get to, like, what kind of crypto's in there? And you look at a program like this, and it's like, oh, they did static crypto keys. They did zero vector initialization. They just stored your password. And let's look at a program like that. Let's go after the login sequence of this application. This is the best keylogger. .com. A little arrogant. Oh. So this best keylogger, it's a program, I think it's like 4 years old now. They've actually been improving it, and I've seen, I think, 6 versions of it since I started showing how bad it is, and they just refuse to fix it, so I hope they watch one of my presentations eventually. I don't know what's wrong with them. So their password validation, so if I go through and I deobfuscate it, it's in class unlock method _5. If it is obfuscated, it's in u function AF. Do you guys have a preference on seeing it obfuscated or deobfuscated? Do you care? Okay, we'll go obfuscated. So we'll go to UAF. So U, AF. And so, like I said, this is obfuscated. So, yeah, right? Like, it doesn't take 2 seconds to be like, this is a shitty piece of software. You come into an organization and they're using this, and it's like, well, you're using shitty software. How would you know that unless you saw it, right? So, how would we attack this, right? We could certainly come in here and find that check. So this is a branch on false. The period S is a jump short as opposed to a hard jump to a target location. Change that to put a not before it. And so that's that, right? But let's look at it. Here's the IL. This is load argument 0. So this is always the 0th argument. You probably remember that from way back when, right? And then here's your text box that you're taking in. You get the text. Okay. You trim it down. So the user enters something, you trim it, and then you start again. This is a stack. This is just another stack, right? This is argument, 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 variable, variable, variable. Take the panel, take the settings, get the current password, so the stored password, and then do a string comparison. Op equals takes 2 strings. And this is an if statement right here. This is what an if statement truly looks like. Op equals, and then branch. We know the password comes in right here, right? It's on the top of the stack. So I'll add a new opcode here. I have the opcode down here. I can do something like, let's say, call. Down here, I show you what call does. Every single line of IL I've tried to associate with the corresponding one, so you don't have to look it up, so you can quickly see what it's doing, right? So, call, target method, target the method. We'll go to System Windows Forms, message box show, and now we have that string that is the password with the message box show, right? I would, of course, bork the code. It would show you it, and then it would bork, right? Let's come up here to this initial one, where you get the user entered password and just start deleting it, right? Because we don't care what they entered. So we'll just take that out. And now we have this op equals. This op equals takes two strings and returns a Boolean onto the stack. So this is expecting a Boolean, right? So we'll supply that a Boolean, ldc.i4.0. So integer 4, 4-bit integer, 0, because .NET decided that they would save some room by hard coding 0 through 8. And so you can now know that when you put a 9, it turns into multiple instructions. When you have an 8, it's one instruction. And so there's actually a difference between 9 and 8. So you can know those little tiny details that you would never know underneath. Of course, 0 is false, 1 is true, right? We'll just take care of that op equals. And so now here it is. And so that's what this gives you. The password, and it wins, right? We still have that not here, so if it's not true, come in, flip this back to a branch on false, and that's it. Save it out. And now we have a edited copy. Automatically append edit because I do it all the time. We'll open it up. So we'll put in some password. Okay, set the password. Close it up. And did I bork it? Show message box, password, show. Anyone see any problems?
Still leave the lower on 0. So this is instance. Lower on 0. Remove it. I think it's okay on release of the stack.
Okay, let's see it. If I put a cheat sheet, bypass. No. Okay. Got the panel, got the settings, get it out. I'll redo it in 2 seconds real quick. And so, just to show that same thing in a fast mode, instead of doing all of that, I would do a insert IL, do a dupe. So now I took the top remaining item on the stack, replicated it, do that call again, and System Windows Forms, message box. I hope you guys clap at the end of this if it works. I figured it out. When you do a show message box, it returns onto the stack, and so it pushed a dialog result. That's what I messed up. Okay, then we have this op equals. We'll put after this op equals a pop, so it did the check, whatever happened, removed it off the stack, LDC I1. And so now it looks like this. Here's your, what was inside of the if is now outside of the if, which is fine. You show it out, and so the same thing I did before, just less lines of code. And here it is. The password. Thanks. And so that was password validation. That's crippling this application. Which, as you saw me in the fast mode, you can just bam it out. You can just get in there and finish it. And once you know, it doesn't take long to get to what you want. I'll get to how you figure out what you want soon. Public and private key, you'll find this all over the place protecting your applications. Just change the key. Instead of trying to crack the key, just put in a new key and rekey it like you would do for a lock that you didn't have a key for, right? This is, for some reason, just what I see everywhere. They take a known value and they take your name and ID and they compare it to a known value. All you have to know is that known value. So just find out what that /b variable is. You can call the servers, right? And you'll have all sorts of phone home mechanisms. You just hack that call. You repoint it to your own servers or you just bypass the call altogether. Demo equals true, just set it to false. This works more for programs that were developed by programmers from the 90s. Yeah, there's a lot of them. Complex math, they just use this and they think it works for some reason. It's actually pretty fun when you come up against it because it's like a Rubik's Cube they meant you never to solve. And after just a few hours, you can start unraveling and find weak points and break your way through it. It's actually pretty fun. And way more than 1% of the time, they will ship the key generation function right next to the key validation function because they took an off-the-shelf library that then generates and validates, and they stuck it in there. And they didn't read through their code, and you can, and it's right next to it. It's like validate key, generate key. So that helps. Like I said, if you can't beat them, join them. Just set your key to something easy. The replay attack is actually really fun. So you take in your username, it goes through some algorithm to change it, it then compares that algorithm against the registration code. When they don't match, your program doesn't register. But you know what it wanted to be, right? So then you can play the same game again, put in the same name, change your registration code, and now you know what you should have had to register. And that's easy. You can use the validation to sometimes undo the validation. So let's look at another product. Like, what does a real application that's making millions of dollars actually have as protection, right? Like, we can look over how they protect it and see that it's only 6 clicks. Just as bypassing that password validation is in there, you can now bypass a registration mechanism of your arbitrary application, turn off phone home, and own it. So just kidding. But he unfortunately left early, so if I can get a couple of volunteers on Twitter, they can get some free CDs. If you guys could Twitter that I'm cracking his software and showing how to break it on stage. He hates it that I crack their software. And I keep telling him that, like, yeah, I broke it again. Good job. I mean, good code. And he hates it. So if you Twitter it, you get a CD. So I'm sure he's on the train, and if he can see, like, oh yeah, Jon McCoy showed how to crack your software. Totally cool. He'll find that hilarious. So let's look at a competing product, since I didn't want to go after his. This is Memory Profiler, which is pretty much the same thing. What does it take? So here's Memory Profiler. We'll run it. I run it inside of sandboxes, inside of a virtual machine. Sandboxes help you dissect your target. Virtual machines help protect you. Technically, sandboxes help protect you, but not really. So this is Ant's Memory Profiler, and no, it expired, right? So we'll take this. So Gray Dragon, as this program booted up after Gray Dragon, it didn't know about it. It scanned memory again. It found that it's 64-bit, inject in, and now we have our bootstrapper. We'll take this payload, drag and drop it. So this is a crack that you would get off the internet and use on your program, right? But how do you know it's clean crack, right? Because if you're using some dirty crack, you could get infected. So open it up, and now you can look at how my tool works. So here is this application, and this target box unlocks this, right? How does it actually work? We'll open up the form. Let's see, this one probably, picture box target. Okay, so this software that cracks this software, here's the secret sauce. So this target targets the window. It calls dialog result okay because if you don't register it, then it says not okay. If you do have a registration or a evaluation, it says dialog result okay, and then it closes the trial window. That's it. So this takes out the entire line of software validation for their entire product line, all of it. Over 2 years ago I showed this, and they still haven't fixed it. This is the newest copy. Like, software doesn't evolve like you think it might in the real world. And you can look at this and say, how does it work? How does this crack work? And then you can write your own, roll your own, use mine, whatever you want. Let's go a step farther. So we're inside of here, and we have access to this bootloader. We'll load up another chunk. So this is also what you'll find on the CD. I call them spikes because you have a better word for it. So we'll load up something else. So I'm injecting application after application, and it just runs arbitrary void mains. This spike happens to be a little bit self-aware. So we're inside of our target. I added buttons to a form. You're programmers, right? You know that's trivial. But getting a hold of the form to do it isn't trivial. But you can look at my code, you can look at these spikes and see how to do it. How do you walk? And you can see plain code, how do you do this? It added this, so you can go through and just change the text in memory. You have that editing window that I showed you before. So you can pick any arbitrary color you want. You can pop stuff across like I showed you. You can drag it around. Oh, all this is locked in, so it doesn't. Oh, and I'm inside of a sandbox, so it tried to open a web browser, and the sandbox said, hell no, you can't. Really nice, right? Because you don't want your software being like, hey, guess what's going on? Because you would not imagine how quickly you'll get detected by AVs and different things and signature, blah. So this continue button, I added an enable because I would keep getting in applications and be like, I just want to click it, right? So you can enable everything on the form. I've actually found some installers, and that's rather nice. When it's like, you don't have the base software, I'm not going to let you click next. Get into some trouble that way too. And this one, ask, is actually one of the PowerPoints that you'll want inside of here. This -R, I meant right click. So it adds a right click to everything. This button, when you right click it, it shows you what does that button do. In order. So I reach into it, I find the delegates, I take the delegates, I find the reference, I go to that function, and I show you the IL of the function, right? So what does that function do? So the first function is show me all the functions. So someone thinks I should remove it, I don't feel like it. But first function is show me all the functions that this button does when you right click it. Second function is what it actually does. So this is all the IL, but up here at the top, I showed you the class and the function name. So when you're going up against obfuscated applications, you can deobfuscate them like I showed you against the AV, or you can just know, okay, it's this bizarre symbols dot other bizarre symbol with this function. You can get in there, get to this function, and just play with it. Like if you want to add your return true, if you want to bypass that Boolean, you can attack obfuscated applications pretty easily. And this is how you do it. That's the activation, which is pretty close to the key validation. Or it's the password validation, which is pretty close to the button, right? So this is how you know where you're going when you attack a target. So back to the crack we're doing on this. Take this, drag and drop it, boom, that's it. Thanks for letting me have your software for free. Now think about it, that was 2 lines of code, right? So I had to get into that form, find out what it does if it succeeds, replicate that, get to the target, implement that, 15 minutes from start to finish. So that's kind of the turnaround time on this. Now you can see that dialog result okay close doesn't cause any systemic changes to the application. You don't have to worry that it's going to mess up the write to hard drive. It's not going to mess up the network protocol. It's just, I called dialog result okay, sure, why not? So this is where that stability comes in. You can quickly, without much knowledge, actually reach in and just edit your application and have all of that power that we've heard about at your fingertips to use on a good basis as well as a negative basis. And hopefully you do both, or either. I'm arbitrary to it. So I click load, it adds these buttons to any form that it finds. And so typically, you can use this to do stuff like get me all the secure strings out of the application, because if it's important enough to protect, I sure want that. And you can start thinking like a bad person would when they come up against an application. You can start coding with a little bit of security mindedness in it. Because as web developers, we know to do security, but as desktop developers, like our security model is, it's paid for. That's our security model. And I hope Hadi likes that I didn't break his keys. So yeah, Twitter it, you get free everything training. So what stops this? What's the security, right? The Microsoft secure development cycle. You can use secure USB dongles. You can phone home and do a registration check. You can look at the registry. You can call the database. You can Twitter, whatever it is. You can update your software. And then you have your crypto on there, right? These are the weak spots, because this is made by logical programmers. If you did a phone home, you know you would have it in one function, right? You know you would have a constructor that has the target URL. You know you would have the keys for the crypto in that. In that one class, 2 functions, 3 functions, you can quickly get in there and know the programmer's paradigm and affect it quickly. That secure USB dongle, it's usually a baked-in, off-the-shelf thing. You can just know what you're looking for a secure USB dongle and attack it. Any product that uses that specific library, the same attack works. In crypto, replace it with just ASCII, and suddenly this hard application with all the security becomes, it writes everything to disk in plain. 2 lines of code, or SQL or whatever injection. This is what, as developers, we usually think our application looks like. It's impenetrable, it's solid, it's developed to be resistant and resilient. Let's look at something. This is a application.net. I injected it just a minute ago with this validation. You drag and drop it into Grey Wolf, and it's like, I don't know. It's packed. It's packed with a C++ wrapper. It's not a thing. How do I deal with it? What do I do with it? So this program that we attacked earlier, how about some CDs? I'll hand out a grip of CDs to the area that someone answers it. How would you get this program? How would you start going after it? Like, you know their commands, right? Let's give up on disk. In memory, how would you go after this? Where's your target? What do you do? Anyone? The what? Again? C find? EXE find? Dig through memory to find your target manually. Just attack the UI plain. Okay, try and find something like the OK and see if that gets you past it. That's it? Okay. It's challenging stuff. Someone want to hand these out to these areas that answered something? Someone near the end? Thank you. And I'll send one over there eventually too. So, what do you do? Well, we know the code is in memory and we can dig through it. So we target it. We use the PID to inject into our target process. So we don't even need to find our target. We're just inside of our target. All we have to do is, now that we're inside of our target, we can go around and affect the memory. We can go around and find objects and affect them, right? Instead of that, we reflect on ourselves. We are inside of our target. We look at our own source code. And with that access, we're able to get access to the source code and thereby normally look at it, but I'm doing research and tools that will soon modify it in memory just as easily. So here's code access, another spike, drag and drop it in, and show code base. And then here's the payload, here's the code base, and it's obfuscated in memory. And so this is the IL of the protected code in memory. So you've blown right past that first level of hard shell. And everything that you can do programmatically, you can do undo programmatically. And that's what I'm bringing you, the opposite. And for every group that is developing new protection mechanisms, there's a group developing unprotection mechanisms. And so far, because of researchers that are to be named, work diligently to fix the problem of obfuscation and protection, giving people like me, pen testers and security people, the leeway to sell our services, that you need someone to vet your software and tell you whether you're using good or bad practices to defend your intellectual property, your security systems, and whatnot. Because this is a protected application, I have its source code, and just as easily, I can execute the same attacks. So that this is what the obfuscated code looks like. When you know what you're looking for, you're looking at a getter for a Boolean, you can assume what it does, one way or the other. And then you can put checks in there to find out what it does, or set it to go the other way, whatever way you want. Because obfuscation in the end just makes it a little harder. It just adds a little bit of time. But as an attacker, because as developers, we get into this development mindset. But as an attacker, obfuscation is your friend. Because let's say I make a rootkit, right? And I want to hide that rootkit. I don't want someone else to come and find it. So I get a call from a client, they're getting attacked, there's some sort of malicious software, and I have to read through 10 megabytes of obfuscated code versus 10 megabytes of unobfuscated code. I can say in the unobfuscated code, I am very sure this is your infection or it's clean. In the obfuscated code, I can say I'm kind of sure, I'm fairly sure. I don't find any TCP communication, and that's what the payload is using. I don't find any of this. I read through most all of the code. I think I understand it all. I de-obfuscate it as well as possible. But obfuscation is your friend because it's easier to hide here when you're an attacker. And so it's a trade-off. When you have obfuscated source code, and it turns out that Microsoft took the approach of using zero obfuscation. This is because they have to deploy it enterprise-wide. And the moment they came up with obfuscation, there was a group that did de-obfuscation, and they looked like idiots. So instead of getting hacked repeatedly, they fixed the problem. So if you want to consider Microsoft the largest contributor to open source software, by all means, say thanks. And that's the difference. Are you building your software to be defendable? Are you building it to go out and crush people? Are you building it to be useful and helpful in developing? And not deciding to defend yourself because you probably won't be attacked. And we get to choose that. What are we shipping? And that security, well, we're hackers. We have all of the power. We're admin on a box. When we sit down as developers, we control the software. We build the software. We own it. And that's what I'm bringing you, that power to say, no, the door is locked and I'm going through it anyways. Because when you really go up against software, you want to bring as much power quickly, take care of the problem, and move on to the next problem. It's just like the development cycle, just in a different paradigm. And because imagine that you're an aggressor for whatever reason, and now you can infect the update call, or you can infect the Twitter keys, or you can infect the USB dongle. It's these things that a pen tester comes in and evaluates to say your software is weak here. You should not do this. You are vulnerable to this type of attack. And then you can choose. Do you want to mitigate that? Do you want to change it? Or just say, well, whatever. That doesn't really matter in this scenario. So let's look at that. Let's look at some software, say a common piece of software like Visual Studios. You would all like it to be secure, right? You would hope that there was no arbitrary code execution that would totally own you and just wreck your day, right? I'm here to help that. Because Microsoft doesn't want to fix a known vulnerability that will totally own you. Because it turns out that there's a core feature in Visual Studios. Anyone guess what that core feature is? That's right. When you have a user control, it executes the constructor on your box as Visual Studios with your rights, and it's a 2 gig footprint. This footprint is so big, AV just says fuck it all, right? So you're immune to AV, and you're inside of a process. If it's a web developer, an admin process, you have keys, you have the ability to push source code to go to the entire development enterprise. You have God mode inside of a company because of this one little feature that Microsoft refuses to take out. So, ILSpy, common decompiler. I thought I would show you the attack sequence. It's actually quite fun. So, here's an application. It's a cute little application. It has an about box, Okay, that's nice. Maybe this is an application I sell. Maybe this is an application I put up as source code on Codeplex or whatever. Take this application, drag and drop it in your decompiler, save out the source code. So we'll save the source code here. Okay. So here's the source code. I decompiled this. This is a common reverse engineering step. Say you take a off-the-shelf piece of software or a piece of malware or whatever, you're decompiling it. You open up Visual Studios. So we're in Visual Studios. Here's our application. So the logo.cs, a user control, is infected. We'll open it up. Okay, that's fine. You open up the about box, and arbitrary code runs. So by looking at it, not running, by looking at it, you're executing arbitrary code that you pulled off the internet, right? Now that's deadly. And Microsoft has had this since 2004, and they're not going to fix it. It's in 2012. I bring it up every single time they talk to me, and they refuse to fix it because it's a core feature of Visual Studios. And I can own anyone that looks at my source code. So that's all cute, right? So you see what's going on here, right? So I have live access inside of the memory space from them looking at this form. So we'll come up here to, let's see, add new data source. And let's see, I have my bootstrapper up because why wouldn't I want to load more into Visual Studios, right? Now think about this. You're inside of Visual Studios, so whether you're attacking something, maybe you're attacking something inside of Visual Studios, or whatever your attack sequence might be. Maybe you just want to get inside of Visual Studios and have some fun, right? So we'll drag and drop. Ooh, running out of space on the windows. Da, da, da. Okay, we'll just go. Where is it? Okay. Yeah, you guys were right. Okay. So, yeah, it was modal. If I got in there, I can make it unmodal, right? Like, that's an annoying feature. So, I'll load up this. We'll come in here. We'll add some buttons. And now Visual Studios is malleable. Now you can come through and say, I want this to be different. Let's see, maybe, yeah, lead it, whatever. You can pop it off, enable everything. And now Visual Studios is malleable. Core applications, SQL Server Management Studio, major applications that we rely on are completely malleable to someone with a high school level of programming knowledge, much less us that actually develop full enterprise software, know the paradigm this was developed in, know how to get to our target, be able to ask it, what does this do? What does this function actually fire? What class? What function? I want to go in there and change this. Now when a program doesn't behave like you want, it throws that error, you can fix it and then ship that fix back to the developer and say, hey, fix your code. Here it is, here's your fix. And that's what's here. I mean, completely weird things that we would never expect we have the ability to do. This is live. This is a live view, and this is changing actual source code. Every time that color changes, the source code is changing. You save this, you're saving that source code. This is all from looking at a form, and Microsoft is going to keep this. So say thanks to them when you're developing things with this, right? So you don't have to inject. You can just use features inside of your target to get in there. So thanks, Microsoft. And if you talk to them, ask them to fix it, right? So you have access to their box. You have developer keys. You have the sign keys. You own that enterprise at that point. Because Microsoft loves the malware. That's why they keep this feature. Because they won't mitigate the rights of the thread. They won't mitigate the rights of the app domain. They won't use their own things to protect you. They just run arbitrary code. It's a feature. Fuck it all. And the real security face of desktop applications is there isn't one. applications are on a secure network. Applications are on the box. Microsoft says, well, you have admin, we can't protect you. And most of the time, there is no real security down there. It's just the wild, wild west. So let's look at what the wild, wild west looks like. So here is the best keylogger. So what else would you like to do with the best keylogger? Well, let's say go after this function. So if I deobfuscate it, well, why don't I do that? So I'll import it, the best keylogger, the edited version. So maybe it doesn't. So save it out. So this is the one with the password bypass and deobfuscated. Load it up in here. And so now this is deobfuscated. You might be thinking to yourself, like, why is there something like after install form? Like, how did that come back, right? It turns out there's metadata all over your forms, and you can use that to inform the name and be able to get well-named things back, like check update. And now you know, well, now I have install button click, and there you go. This was protected application becomes easily viewable and editable application. When they do it programmatically, we undo it programmatically. This attack sequence. So let's look at that. So generate control method _2. So general control method underscore. So they took the extra step of adding a general control to the obfuscation sequence. It takes a string. This is the string class. So this is an activation key class, as you can see there, that was obfuscated and now is deobfuscated. Oh, that might be interesting because it has an activation key. Well, that could be handy. So we'll go through and delete 92, 97, and 102. So 92 to 102, right? So that happens to be a web reference call. So let's boot that up. This screen space thing, okay. General control method _2. Show IL. Show IL, unshow C#. Okay, so that was 92 to 102. 92. Delete, delete, delete. And change this 115 branch on false. So we checked with the server. Instead of checking, we didn't. And then, yeah, if you didn't check with the server, continue. So as that code would be hard to see, this has a not activated. So as long as it's not activated, succeed. So come in here, open up the good solution. So as I said before, kept the show me the password because I don't want to remember that. That's nice. I can't click it. It's not registered. Okay, settings, general settings, license application. Oh, delete, speak, 2012. Oh, cool. That happened to be the key. So that's it. That's a couple of clicks. That took a little bit to find. And it's like, okay, now you're registered, delete, speak, 2012, full edition, never expires. Thank you, winning. So that's going through, taking that protected call that goes out to the web, turn it off, and take care of it. So whatever their protection mechanism comes down to, it comes down to a logical choke point. You can affect it. You saw those lines that I identified and said what to do, delete this line, delete that line, add this line, change that. I'm turning out a new tool, and it's called Gray Fox. It takes what I do with Gray Wolf and automates it, so you can say this line, this change. So when someone ships you a crack, it says flip this if and you're done. You can look at that crack and then apply it and not have to worry about your crack being infected. So now you can take your changes and automate them and turn out your impacts, your upgrades to applications, and send them out over text files that people can easily do by hand or automatically implement. Hope you like that feature. It's still under R&D. It's pretty janky right now, but it's getting there. And so, okay. Good job. That's quite nice to get. Okay, so, and that's where we're going. So, as you guessed it, I'm of course going to running assembly code in .NET. I'm going to combining C# and Java in .NET. This is where I'm going. I'm going to give the ability to take assembly code applications and push them into pointers. Take Java jars and push them into .NET space. And hope you like the upcoming research and enjoy this tool set that's free, completely free. Use sandboxes, use virtual boxes. These are the applications I recommend. When you look inside of your applications, you can now see what's truly there. You can know what their crypto is. You can know what they're leaking, what they're sending home. You can know how they're doing it. You can know whether you could improve it. Thank you.